Okay. So can you see me? Everything's good?
Yep.
All right, excellent. Okay, well, I'll get started. So I guess I'll start with an introduction. My name is Rick Weissenborn. I started Tools4Boards 30 years ago. Hard to believe it's been that long. I started with an invention. So I invented a ski vise. I sold it through a company, a Norwegian company called Swix, and subsequently patented and developed 7 subsequent products that we sold through Swix on a global basis. And more recently, we supplied Burton snowboards. And then about 15 years ago, we created our own brand, Tools4Boards, to market and distribute our own proprietary products. So that's my background. I've been doing this for quite a while, so hopefully it'll be informative for you. The way that I structure the clinic, I normally go through every step from start to finish. So I'll do that this time. Feel free to ask questions. It's an interactive session, so if you have any questions, I'm happy to answer them. So everyone good?
You bet.
Okay, so to get started, I always use a vise to hold the ski. I never freehand the ski or attempt to sharpen the edges or wax the ski without having it immobilized. So it's really important to have a good set of vices. We manufacture several different kinds. We've got very simple vices that are basically static supports with a bumper and a placement for vertical placement for preparing the edges. There's rubber pads for placement base up on the supports. We have more elaborate vices like the one that I'm using here that mechanically hold the ski and prevent it from moving. So I'll run through the steps of mounting it in the vise and how I go about that. Basically, I'll always start with the ski on its side, okay, as opposed to working on the base first. I always start working on the side of the ski. So I'll position it this way and clamp it. This vise is great because it comes with C-clamps, so you can mount it on any workbench, or it mounts directly to our tuning stand. This is a table variant, and the vise components fit in the slots on this rail, and you can quick adjust the length of them depending on the length of the ski. You'll have to retract the brake. Okay, so you need to get the ski brake out of the way. There's a couple ways to do that. We have brake retainers. This is called retract. So you can loop this around both brake arms. You have to be careful with this binding in particular. The brake has a bit of a kind of a lock position that you have to overcome in order to retract it. So that's one way to get the brake retained. With this vise, it's called a Lasso Vise. It has a cord and a cleat that's mounted on a C-clamp. So if you take the cord, loop it around the top brake arm, there's a jam cleat integral in the clamp frame here, and that allows you to retract the brake. That's a very quick, easy way to do it, as opposed to using elastic bands or broccoli elastics, that type of thing. So I'll retract the brake, and then the ski is set up to work on the side. Now, the first thing I'll do, especially with used skis, is I'll basically feel the edge gently with a finger tip. Okay, you have to be careful if there's any burr portions on the edge. You don't want to cut yourself, but just gently run your finger along the edge. And normally when you go skiing, you tend to hit rocks, even though you may not think you have. And so it's important to identify where the damage is on the edge. Okay, so with my fingertips, I'll feel, if I feel some damage, normally when you hit a rock with the edge, there'll be a dent or a ding in the edge, and then around that, there'll be a hardened portion of edge. So when you hit a rock, the edge gets really hot quickly and then it cools quickly. And so it hardens the metal. It changes the molecular structure of the metal and makes it much harder. And there's a bit of a crust around the damage, okay? And if you don't remove that before you start using a file or a stone, that damage is as hard or harder than the teeth on a typical high carbon steel file. So a typical ski file won't cut, won't bite over the damage. So basically you'll end up using the file. The file will skid across the damage. It'll make a whirring sound. It won't cut, and you'll end up dulling the file and you're not sharpening the edge. So this is a really great kind of hack initially before you start any of your work to get rid of any rock damage before you start using a file or a stone. And that'll increase the life expectancy of your files quite dramatically. And you won't damage your diamond stones. I'll run over diamond stones in a bit, but basically your files or stones, you'll preserve them for your final finishing as opposed to using them for rough work on a damaged edge. So in order to do that, I use an aluminum oxide stone, okay? So this is a German-made stone. It's actually not expensive. They're $4 or $5, so they're inexpensive. And the aluminum oxide will remove that crust or that rock damage quite readily. You can use diamond stones to do this as well, but I tend to save my diamonds, as I said, for working on a more pristine edge. This is an inexpensive way to remove all the rock damage so that you can prolong the life of your files and your stones. The way that I do this is anywhere I feel damage, I'll basically put the stone on the surface of the edge, flat against the side, and also flat against the base. So I'm not dulling the edge. I'm not putting it at a 45-degree angle. I'm just following the flatness of the edge on the side and then rubbing it back and forth on the base to remove any rock damage. Okay, so that takes care of it very efficiently. So I'll run down the entire length of the edge. Anywhere I feel any burrs, I'll just rub against the side, rub against the base edge, okay, and that'll remove any rock damage. Once I've done that, the next step in the process is to address what is called the side wall. So, any questions about rock damage removing? No, we're good. Okay, so now I'll address the side wall, and the side wall, if you're not familiar with it, is what's called the edge offset. It's a shelf that's directly above the edge, okay? And then there's a step, an inward step that goes to the side of the ski. So it's not the side of the ski, it's actually a shelf that supports the edge, and it's designed to be taken down along with the edge. If I don't take the sidewall down periodically, normally if you use a file guide, for instance, and you sharpen the edge with the guide, you'll think that you're sharpening it at the prescribed degree of the guide. So in this case, this guide is 3 degrees or 87. But a file will cut the metal readily, it won't cut the plastic. So eventually, the plastic becomes higher than the metal, and it'll throw the angle of the file off. So you can actually put a negative edge angle on the edge, okay? So in order to prevent that, what we do is we take off some of the plastic beside the edge, just enough to expose more metal for filing. And the way that I do that, we have a tool called, this is called Cut. There's a green bar, and the green bar is a 7-degree angle, the surface. And so I'll put a coarse file on the guide. This is what's called combi cut. It has a bastard cut side, and then it has a very coarse side. I'll use the coarse side. You can also use a Panzer blade or a curved tooth file that's used for automotive work, auto body work. They have files. We import them from Europe. They're very hard and sharp and flat, but it's a curved, coarse tooth. So any files that are very fine, or a typical bastard cut, second cut, fine cut file will not cut the plastic. You need a coarse file to do that. So we'll use the coarse file. I'll position it on the guide. I position it at a bit of an angle like this, and I clamp that using a spring clamp, okay? And then I'll position this on the side of the ski along the edge, and I'll pull this towards me, okay? And that's taking down the black material beside the edge, okay? Normally, I'll use a Sharpie. A Sharpie is the easiest way to figure out what you're doing, okay, relative to what you're doing on the edge and where the edge is to begin with. You can actually identify the bevel angle of the edge as long as you have an accurate tool. So in this case, our guides are very highly accurate. What I'll do is I'll use the Sharpie to mark the edge and the side wall. Okay, so the black plastic in this case and the metal edge. I'll do that at the shovel of the ski. I'll do it underfoot, and I'll do it at the tail normally. And then when I draw the file down the length of the edge, it'll be removing the side wall, and I can see how much side wall is being removed. With a black sidewall, it's difficult to see with a black Sharpie, so better to use a silver Sharpie, something that contrasts. If you have a light colored sidewall, a black Sharpie works fine. Okay, so I'll mark the edge. This is at 7 degrees. I'll place the file on here, and I'll draw it towards me down the length of the edge. Okay, and you can see that it's removing the Sharpie towards the metal. As soon as you start to cut the metal, then you stop. So it's self-regulating. If you keep going, cutting the metal, you'll end up with a 7-degree edge angle, and you don't want that. You just want to remove the plastic to expose more of the metal edge for filing. Okay, so as soon as you start to cut either the second edge, it's called the second edge, it's a titanium plate above the steel edge, or the metal edge, then stop and you're good. You've removed just enough material to expose more of the metal for filing. There's other dedicated tools that do this called carbide cutters that I don't recommend, especially for novice users, beginners. They tend to take too much material. So it's a carbide cutter that you basically draw it down the length of the plastic, and it tears the plastic, peels it away, and it almost always removes too much material. The sidewall is a structural support for the edge, okay? So if you take that material away, structurally there's nothing there to support the edge, and the edge will collapse. And in extreme cases, it'll collapse and won't come back, in which case your skis are wrecked. There's other instances with sidewall cutters where it's difficult to apply uniform pressure down the length of the ski. So you get a washboard effect. You dig in and then kind of, there's less pressure, and then you apply more pressure and you dig in again. And it's very difficult to remove that, to sand that away. In some instances you can. Also, in extreme cases, I've seen people cut into the side of the ski itself, okay, which weakens the side of the ski, and it causes delamination. So they're kind of dangerous in that respect. I tend to gravitate towards a file guide because it's safer. There's multiple teeth in contact with the plastic, so it doesn't dig in, and you only remove just a very minimal amount to expose more metal for filing, so your skis last a lot longer. It prolongs the life of the skis quite dramatically. Servicemen tend to gravitate to sidewall cutters because you can remove a lot of sidewall material at once. It's convenient, but it's not good for the skis, and it can be an expensive mistake if they're used incorrectly. So,
Rick,
this type of guide.
Rick, sorry. So the sidewall are you actually removing material? Sorry, is it on the base of the ski? So you're peeling it back from the edge, or is it on the top portion?
It's on the top portion on the side of the ski.
Okay, just on the other side, on your side.
Yeah. So if you see, I've got the file protruding from the guide a bit here, right?
Gotcha.
And then I'm placing the guide is propping the file at 7 degrees.
Okay.
And then that's allowing you to cut the plastic material.
On the other side there. Gotcha.
The metal edge is typically set at 3 degrees or 2 degrees. There's basically 3 ways to call it an edge, okay? You can call it, let's say 88 degrees, okay? Or 92, depending on where you measure on a grid, or the angle itself, which is 2 degrees. We tend to call it what it is. In our case, it will be 2 degrees. 87 would be 93 or 3 degrees, right? So the metal edge is typically either 2 degrees or 3 degrees. And the 7 degrees is more acute. So it'll plane the plastic material, and then, but it'll leave the 2 or the 3 degree edge intact, so that then you can run over the metal with the 2 or 3 degree edging.
Okay.
With the guide, right?
Thanks.
Okay. So that's a step. Basically, with any file or stone, I always angle the file. You'll notice that I angled this file. So ideally, I want to minimize the contact, the length of file in contact with the edge, okay? Because that maximizes the efficiency of the teeth cutting the edge. So if I put the file, this is a relatively short file, but it's still basically, if I put it in line with the guide, only the very front and back teeth contact the edge, because there's side cut in the ski, right? There's a concave shape to the edge. So if the file is straight in line with the guide, the tool is very stable fore and aft, but you're only contacting the very front and back of the file, which is very inefficient. So what I'll do is I'll angle the file so that about 45 or 50 millimeters is contacting the edge, okay? And that is optimal because it minimizes the length in contact, but it provides enough fore aft stability for the tool. Does that make sense? Okay, so
one quick question: how often should we shave down the sidewall every time, or is this something kind of every few times we should do?
So you know, using a sidewall cutter, the manufacturers of sidewall cutters recommend every 3 to 5 times you file the edge, the metal edge, you need to do that again. I don't think that's correct. I think it's important that you minimize the amount that you take off. So I file it with this tool, for instance. You can use this to take down a small amount of the side wall. Then you can rotate the tool onto the other side, which is a 2 or 3 degree guide, and you can file the metal edge. So you can easily do it at the same time. So,
okay.
So I suggest doing it every time you sharpen the edge. And that way you're minimizing the amount of sidewall you're removing, and you're maintaining the structural support for the edge, for the metal edge over time, right? Okay, so after I've done that, I'm talking about files. Basically, with files, I'll always pull the file. So I talked about angling the file, positioning it at an angle, okay? In terms of using it, there's arrows on all of our files that indicate direction of cut. So all of our files are made in Switzerland by Velour, this company that is a couple hundred years old. They started manufacturing files for the watch industry, actually. So farmers in Switzerland had nothing to do in the winter months. They started making watches, and then this company came along to support the watch industry. And they actually use Velour files on the International Space Station. And so we sell very, very good files. And I prefer to source the best materials because they last longer. They do a very accurate, precise job, and you don't end up throwing them away, you know, early and having to buy more tools. If you invest in high quality tools, you tend to get better results as well. So so just as an aside, so our files, this one in particular has 2 different sides. So I use the coarse side for the side wall. Then I'll flip it, and there's a faster cut side, which is a finer side. I'll use that to sharpen the metal edge. It's what's called a a bastard cut or a first cut file. So that's typically used first. Files, high carbon steel files are used in progression normally from coarse to fine. So a bastard cut, second cut, and then a fine cut. We do this because the process of making a file, it's interesting. It's actually a soft blank. It's run through a machine and the teeth are vibrated on. So the teeth are what's called struck onto the blank. It comes out and then electrodes are placed on either end. It's brought up to a red hot temperature, quenched. So it's quickly cooled and that hardens the file. That process, even though these files are extremely hard, sharp, and flat, there's certain imperfections, and you can mitigate those imperfections by using a series of files in progression, so from coarse to fine. So that's what we tend to do with files. These high carbon steel files, they come in two types, basically. There's either non-chrome, okay, or chrome plated. So non-chrome tend to be a bit darker and they're sharper because chrome plating basically coats the teeth and it makes the file a bit duller and it has a bit of a softer feel. About 30 years ago, a company in Finland started chrome plating files and it caught on basically as a marketing argument. It doesn't prolong the life of the file, but it will prevent the file from rusting, whereas a non-chrome file will rust quite easily if you put it in contact with water, which you shouldn't. But if you do, this non-chrome file will rust quicker. I tend to prefer a non-chrome because it's sharper, and I prefer a sharper file when I'm working on the edge. There's another type of file. This is a beginner course, but just to make you aware, there's another type. It's a material similar to stainless steel. It's a special steel that's extremely hard, and the teeth are milled, precision milled in the blank as opposed to struck. And in this case, if you're using this type of file, you'll use one stroke basically down the entire length of the edge with very light pressure. It's a precision instrument, so your skis can't have rock damage or can't be damaged in any respect. If used correctly, this type of file lasts about 10 times as long as a high carbon steel file. It's more of a precision instrument. The high carbon steel file is more forgiving. They're far less expensive. And that's what most people use. But just to let you know, there's two different technologies that we have. So basically, after I've addressed the side wall, okay, I've also marked the side edge with a marker, okay, and then I'm going to use the bastard cut side of the combi cut, which is the finer side. Arrows indicate direction of cut, so I'll make sure that the arrows are facing me, okay, and I always pull the file towards me. So if anyone out there has experience pushing a file and is good at it, that's great. That's your preference. If not, I always advocate pulling the file, because if you're pushing the file and you get distracted, your hand, basically the guide can fall off the edge and you can slit your wrist. So it can be very dangerous, right? So I find that when I'm pulling the file, I have greater control, and you can't put yourself in a position where you can cut yourself if distracted. So I always pull the file towards me. With high carbon steel files, they're designed to be drawn down the edge, okay, and then moved, repositioned, okay, and then pulled again. So I'm making repeated kind of pulling strokes down the length of the edge, okay, not just one stroke down the entire length of the edge that you would do with this other technology, this very hard profile, we call it. So yeah, so I'll demonstrate this. Basically, when I'm using this file, again, I've marked the edge, okay? With the Sharpie, it's really easy to tell what you're doing, okay? So basically, if you're removing Sharpie from the side wall to the cutting surface of the edge, you're increasing the bevel angle, okay? So, and you know what the bevel angle is based on your tool. So in this case, it's 3 degrees or 87. Okay, so in this case, I'm removing Sharpie towards the cutting surface of the edge. That means I'm increasing the bevel angle. If you're removing Sharpie from the cutting surface of the edge to the side wall, to the plastic, okay, that would be reducing the bevel angle, right? The existing bevel angle. If I'm removing the Sharpie uniformly down the length of the edge, so across the edge, I'm removing it uniformly, that means I'm maintaining the edge bevel angle, right? So that's a really easy way to understand what you're doing with the edge. You don't need expensive equipment. There's expensive gauges that measure the edge bevel, the degree, the bevel angle of the side edge and the base edge. You don't need those if you have an accurate tool and a felt marker, a Sharpie. So that's kind of that's another great hack for understanding. If you don't know what your edges are set at, you can easily tell just by using a Sharpie and an accurate cut. So in terms of bevel angle, we tend to, as I mentioned, use either 87 or 88, or in other words, 3 degrees or 2 degrees. 2 degrees is used, it's the most common side edge bevel, okay? And it's used for most conditions. So if you're in soft snow, powder snow, you really don't rely on your edges that much. 2 degrees is fine. It dulls slower than a more acute edge bevel. So if I'm in hard icy conditions and I need more grip, I'll gravitate to a 3 degree or an 87. And in that case, it's a more acute edge angle, but it'll dull faster, right? So at 2 degrees dulls less fast, it lasts longer, but it's less sharp. 3 degrees is more sharp, but it dulls faster. Does that make sense? It depends on discipline, and it depends on conditions. So if you're on hard icy conditions, slalom skis where you need a quick edge-to-edge transition, you may want a more acute side edge bevel. With speed skis, medium radius skis, giant slalom, or speed skis, super G or downhill skis, you may have less of a bevel angle, depending again on conditions and preference, because you don't need that much grip if it's not extremely hard, icy, man-made snow. So it's dependent on preference, on condition, and on discipline. But in most cases, either 2 or 3 degrees is the most common side edge beveling. Okay, so with the file, I made a few passes, enough to remove the Sharpie. Okay, and once I've done that, then I know that basically I've sharpened the edge, right? When you sharpen the edge with a file, basically the way the file works is you end up displacing some material. So you'll have some kind of diagonal striations where you're pushing material off the edge you're filing onto the opposite edge. So in this case, you're pushing material off the side edge onto the base edge, and you'll end up getting a little curl or a burr on the base edge. Okay, that's important to remember, because after we finish with the side edge, both side edges, then we're going to go to the base edge, and we'll finish with the base edge, and we'll knock that burr off the base edge that was created by filing the side edge. Okay, you get a bit of a burr also with diamond stones, which I'll discuss. Not nearly as much as a file, because a file displaces the material. A diamond tends to cut and polish simultaneously, so you don't get as much of a burr with a diamond as opposed to a file. Okay, so with a file, you'll get a bit of a burr. That'll need to be removed. After I've used the file, I basically set the edge geometry. The majority of my work normally 80%, 80 to 90% of the work that I do on a metal edge will be done with stones, with diamond stones. The only time I really use a file is if I'm resetting the bevel angle. Okay, so I'm changing the bevel angle. A file is more efficient. It removes more material than a stone. Okay, but using it frequently reduces the life expectancy of the ski quite dramatically because you're taking a lot of the metal away quickly, right? So it's more efficient to set the edge geometry. It's also efficient if you've neglected your edges, if you haven't maintained them for a long period of time, several weeks, for instance. A file is more efficient at removing more material, so you can refresh the edge more quickly, okay? But you don't want to be doing that if you don't have to. So once I've set the edge geometry and there's no significant damage along the edge, most of my work will be with stones. The other thing to consider is with a typical file, a bastard cut, second cut, fine cut. Normally those are used in progression. A lot of people are gravitating from a fine cut file to actually a coarse diamond stone to take the place of the fine file, the finishing file. So a 100 grit diamond stone, a coarse diamond stone, takes off about the same amount of material as a fine finishing file, but it has an advantage. It'll cut and polish, whereas the file will only cut, right? The other thing with a file is normally all of our, everything we do on the ski is done from tip to tail, from shovel to tail. We always, as a rule, do all the work that's kind of in line with the glide. So you're going from tip to tail, so that's the direction of glide with the ski. The ski is moving over the snow, from the shovel to the tail. So we do everything in that order. When you're filing the edge, for instance, or we're working on an edge, if you're not ambidextrous, you're using your right or your left hand, one of the edges you'll work from shovel to tail. Okay, the other one you'll be going from tail to shovel, right? And if you're using a file, you're putting kind of striations in the wrong direction, the direction that's the reverse of the direction of travel. So that's okay after you finish filing, as long as you're using a stone I'm going to use in both directions. So I'm going to rub it back and forth along the edge, as opposed to the file that only cuts in one direction, right? So running back and forth along the edge will mitigate the striations that are, in the wrong direction when you're traveling with the ski. So from tail to tip, that's mitigated by using stones. So I'll go to my stones now. So I'll explain briefly. Basically, we manufacture diamond stones, or the backers, the plates that we put diamond material on. All of our material is basically Dutch diamond that's processed in Switzerland by a company in Switzerland, and it's extremely high quality material that is the best that I've found. So there's basically 5 different grits that we sell. I can show you. There's 100 grit, which is black, 200, which is red, 400 is yellow, 800 is white, and 1500 is blue. Okay, so that's the full range of grits. As I mentioned earlier, more people are gravitating to a 100 grit stone in place of a finishing file. Okay, so in other words, we're using this to take the place of the fine file to basically set up the geometry, and then it's followed by the other grits in progression from coarse to fine. Normally, a technician will use 3 grits. So they'll use a 200, a 400, and an 800 in progression. Okay, using stones in progression is more efficient than just using one stone. So it's like having multiple pairs of shoes and rotating the shoes. They last longer, they don't dull as quickly, and it's a lot more efficient. You'll save a lot of time because you're using a coarse stone before you use the finer stones, as opposed to taking a finer stone and doing a lot of work, rubbing it back and forth along the edge to do the same amount of work that you'd be doing with 3 stones quite quickly, right? So if you get 1 stone, typically I'd recommend middle grit, like a 400 grit stone. If you get 2 stones, I recommend a 200 and an 800. Ideally, I recommend three stones, and perhaps the 4th, the 100 grit, to replace the file. 1500 grit is used, it basically puts approaching a mirror finish on the edge. So for most people, it's not necessary. If you're a perfectionist, when you're racing, the smoother the edge, the faster it is. So putting a mirror finish on the edge actually makes the skis, the edge a bit faster. In the scheme of things, the degree to which that benefits you is it's not, you're splitting hairs with that. So that's the 1500 grit. So definitely, if you're considering stones, I go with at least a 200, a 400, and an 800 in progression. We have different shapes. So we have a rectangular shape stone. Okay, this. It's either single or double-sided. Okay, and it's placed on the guide the same way the file is, at an angle. Okay, they're used. We always use stones wet. So ideally, I'll get a cup or a mug. I'll fill it with half water and half rubbing alcohol. Okay. So I have water here. Ideally, it would be half water, half rubbing alcohol. Rubbing alcohol is in suspension. It's not pure. So maybe a bit more rubbing alcohol to water to get the 50-50 mix. Okay. And then a couple drops of dish detergent will lubricate the stone in this solution. And what I'll do, using a stone wet will prolong the life of the stone. It actually doubles the amount of useful life of a diamond stone. So if you use the stone dry, it lasts half as long. If you use it wet, it lasts twice as long. So they're designed to be used wet, okay? So half water, half rubbing alcohol in solution, a couple drops of dish detergent will lubricate the stone along the edge. And before I start using it, I'll dip it in the solution, okay? I'll put it on the guide. Clamp it with the spring clamp. Okay, then I'll use an old toothbrush, and I'll use the toothbrush and I'll wet the edge. Okay, and I'll wet the stone periodically, and I'll go back and forth. Okay, as I said, a stone cuts in both directions. Right, a file only cuts in one, and I'll rub back and forth, and I'll continue to wet the edge and wet the file, the stone as I progress down the length of the edge, and I'll keep the stone wet, and that'll prolong the life of the stone. Stones are expensive. Diamond stones are relatively expensive. This will, it'll be a lot more efficient and less expensive for you if you use them wet. Questions so far?
Do you do the file on the base edge or just the stones usually?
So normally I'll only use a file when I'm setting the base edge bevel angle. Otherwise, okay. I only use a stone, and typically a 400 grit stone, a middle grit stone. I'll run over that momentarily. I'll just with the side. So basically, I'll use in this case, it's a 200 grit, okay? I'll rub it down the length of the edge. I'll switch the file to the 400 grit, and I'll do that. Okay, and progressively go to the 800 and perhaps the 1500. You'll notice that this stone is rectangular in shape, okay? So that's a typical shape for a diamond stone. And what ends up happening is when you're using these, you use them at an angle so that you're minimizing the length in contact, but having enough stability, right? And so you'll move it kind of diagonally to use as much diamond material as possible. Then you might rotate it, okay, and use it again in this direction. What ends up happening is you get kind of an X shape wear surface on the stone. So you're not using the entire stone surface, okay? You're only using a portion of it. So to mitigate that, we've created what's called puck, and puck is circular. And so our guides also have a placement feature. They've got plus symbols on the surface of the bar. So when you take a puck and you place it in line with these plus symbols and clamp it, that's the most efficient placement, because exactly the full diameter of the stone is in contact with the edge, okay, the circular stone. And I can also position my thumb over the cutting surface of the edge. Whenever I'm working on an edge with either a file or a stone, I like to get my thumb over the cutting surface, because it provides direct feedback and I get a better feel for what I'm doing, how the stone or the file is cutting, okay? So this allows me to do that. And then I can rotate this as needed. I can rotate it infinitely along the guide to expose a new diamond for filing, for sharpening the edge. And so in this case, it's far more efficient because I'm using the entire surface of the diamond as opposed to the rectangular stones. So that's something to consider. All of our stones are also very thick. They're 5.5 mil thick. This is precision die cast aluminum. So there's very minimal flex with our stones. Some other stones that are plastic backers, or even some aluminum stones, they flex. Even though you don't think they're flexing, they're rolling over the edge as you're running back and forth, even with minimal pressure. And when you roll over the edge, you're dulling the cutting surface of the edge. So our stones are thick and they have very minimal flex and they stay true along the edge. So that's a good argument for either puck or hone. What else?
I have a quick question about that guide. So it's the red side is like a 3 degree, and then the green is for the sidewall, which is the 7 degree. Is that how that works?
That's correct. Yeah. So the way that it's set up, I actually patented this. There's two bars, and the bars are screwed onto a precision milled stainless plate, right? That's the wear surface. And so the 7 degrees for sidewall, you can actually remove the screws with an Allen key, rotate the plate so that this opposing side is facing outward. That's 0 degrees. And you can use this as a scraper sharpener. So if you put sandpaper on a flat surface with the tool, so I've got a piece of sandpaper here. Assuming that I've rotated this bar so the 0 degree is facing out, I can put this on the table and then it acts as a fence, and I can run my scraper back and forth on the sandpaper, and that'll sharpen your scraper, plexi scraper. Okay, so that's the green bar, and then the red bar is the same. Basically, there's two surfaces. This is a 3 degree surface. It's outward facing. Okay, so that's 87 degrees. That's the 3 degree surface. If I unscrew this, rotate the bar to the 2 degrees, it's on the inside. So that's facing out. Then I have an 88 degree guide.
Okay.
For 2 degrees, right? So this is a really cool, because normally fixed angle guides, you have to buy individual guides for each angle. And in this case, you can buy one that does 4 different things, including the sidewall, which is typically a dedicated tool. And sidewall cutters tend to be quite expensive as well. That's that's a great tool. Okay, so once I run over it with my series of stones along the edge, I always sharpen the entire length of edge in contact with the snow. Okay, so any portion of the ski, the edge that's not in contact with the snow, should be dull. So the shovel where it doesn't contact the snow, that should be dull. The tail that doesn't contact the snow, the very back of the ski, that should be dull as well, okay? And then because I always maintain the entire length of the edge, I always prepare the entire length of the edge, I'm going to need to what's called detune the ski a bit, okay? The reason I do that, normally you want the ski sharpest underfoot. Some people will grab a file and they'll sharpen the edge directly under the binding, and that's the only part they'll sharpen. If they do that repeatedly over time, that portion of the edge gets really thin, the rest of the edge is quite thick. It affects the flex characteristics of the ski, but more importantly, I do it to maintain consistency. So every time I do the edges, I'm always doing the entire length of the edge, okay? And that maintains consistency. Then I'll take what are called gummy stones, okay? Or at least one gummy stone. We have 3. These are all German made again. We've got a coarse one that's great for removing rust. If you've forgotten to wipe your skis after you've been out skiing and you come back to them, there's rust on the edges. This is great for removing rust. We've got a middle grit that's kind of a general gummy stone that's quite good for a range of tasks, but specifically for detuning, it worked great. There's a fine gummy stone, and this is used to remove micro burrs along the cutting surface of the edge after you've used files and stones. So gummy stones are really useful tools. If you get one gummy stone, I'd suggest getting the green one, okay? And what I'll do is I'll detune the edge. So detuning means that I'm going to progressively, I'm going to place the gummy on the edge at about a 45-degree angle with quite a bit of pressure. And then over a run, I'm going to feather the edge, kind of go from dull to sharp over a run. So I'm applying more pressure when I start, a lot less pressure when I finish, right? And what that's doing is it's basically dulling the portion of the edge that's closest to where it doesn't contact the snow, right? That's quite dull, and it gets progressively sharper over a run. How I do this depends in large part on discipline, again, and preference. So with a slalom ski, you're going to do very little detuning over a very short run. So with the shovel, maybe it's 5 to 10 centimeters, thereabouts, going from dull to sharp, because with a slalom ski, you want a quick edge set, okay? You don't want it to be a kind of a more gradual set. You want a relatively quick edge set. With a medium radius turn, I'll detune a bit more at the shovel, okay? Maybe 15 centimeters from dull to sharp. Okay, so a GS ski, giant slalom ski, medium radius turn, because there's a more gradual edge set with that. With a speed ski, like a super G ski or a downhill ski, we actually detune quite a bit, okay, towards the toe piece of the binding, because at high speeds, you don't want the edges catching, right? So you have quite a long run where it goes gradually from being dull to sharp, right? At the tail, I'll do the same thing, but it's over a much shorter run, okay, at the tail of the ski, just to prevent the edge from catching if you get on the backs of the skis and onto the tails. It'll prevent the tail from catching. So that's what that is. So we detune both the shovel and the tail of the ski, okay, using a gummy stone. Questions about that? All right. So that's basically everything to do with the side of the ski, okay? I've addressed the side wall, the side edge, okay? Now I'm going to go to the base edge. That's assuming I've done both edges. So I've done both the top and the bottom edge on the ski. Okay, now I'm going to switch the position of the ski from side to base. So it's base up. So with this vise, I'll adjust these pads outward. They basically pivot to adjust to the shape of the ski. And then with this cord, I'll loop it around both brake arms. I'll push the brake down and cinch it in the jam cleat, okay? So that holds the ski against the supports and keeps the brake retracted. Now, with the base edge, you asked the question about do you file the base edge? So normally, let's say we've stone ground the ski, okay, to flat. I'll apply a base edge bevel angle on the ski after getting the skis back from a shop, for instance. They've stone ground the base. Okay, so the base is flat and the base edge is flat. So I'll use we've got a tool for that, a very highly accurate tool called ACE. It's adjustable. There's 0.5, 0.75, 1, and 1.5 degree capability with this. Normally, with a quick radius turn, okay, you'll go with a lesser bevel angle, base bevel angle. The most popular base bevel angle is 1 degree, okay? For most recreational skiers, 1 degree is a very forgiving bevel angle. So why do we have a bevel angle? Maybe I should speak to that. Basically, a bevel angle allows you predictability in the initiation of a turn. So if you don't have a bevel angle on the base, all skis, modern skis, are designed to have a base bevel angle, and you can adjust it to either have a quicker initiation or a more acute bevel angle will provide more forgiveness, and it'll be a more gradual edge set, okay? So for instance, with a slalom ski, a 1/2 degree is pretty typical for a base bevel, 1/2 of 1 degree. For recreational skiers, normally the most common angle is 1 degree. It can be between that, 0.75 is kind of a happy medium. That again is based on preference. If you go skiing and you find that your edges are catching, you may want to adjust the base bevel angle, increase it a bit so that it's a bit more of a gradual edge set. So that's the purpose of a base bevel angle. Normally, when the ski is ground to flat, I'll apply a conservative base bevel. So I'll start with 1/2 of 1 degree. I'll start with 0.5 because I can always increase the base bevel angle if I need to, okay? I can't decrease it. So you can't put metal back. The only way to decrease the bevel angle that's on the ski is to take it into a shop, get it stone ground back to flat, and then reapply the base bevel to decrease the angle, okay? As I said, I'll use typically to set the base bevel angle, I'll use a second cut file normally, I find works best. I'll put it on the guide. I'll mark the edge again with a Sharpie. So Sharpie is a really great, again, a great tool to have. And I'll do it at the shovel, underfoot, and at the tail. And then when I'm setting the base bevel angle, I'll be removing the Sharpie if the edge is flat, okay? I'll be removing it gradually from the base material to the cutting surface. So I'll be applying the base bevel. So that's increasing the bevel angle. If I run over it and I find that I'm uniformly removing the Sharpie, I'm maintaining it. If you can't decrease the angle. So if I'm finding that I'm not contacting the base at all, typically that means that the base bevel is more acute than what the tool is. So it could be quite dramatic. And what I found is that in most cases, people tend to take way too much base off, okay? So they've inadvertently increased the base bevel far beyond what they want, okay? And there's a common misconception that the base edge is like the side edge, it's designed to be taken down. That's not the case. Basically, you set the base bevel angle once, okay? And then from there on, the only thing you do is basically knock the burr off the base edge that you create when you file at the side edge, okay? You're just knocking the base, that curl off the base edge, and that's all you're doing. Maybe slightly polishing the base edge. And I use a stone to do that, typically a 400 grit stone. So again, the only time I ever use a file on the base edge is to set the bevel angle because it's quite efficient, okay, and allows me to do it quickly. You could do it with a diamond stone, it would take a bit longer, but you'd be a bit safer maybe by doing that with a stone as opposed to a file. Once the base edge bevel is set, I only use a stone, in this case 400 grit, okay? And I'm going to be rubbing the stone back and forth along the edge. And what that's doing, make sure that the surface of the stone is above the shim to correctly position the file, prop it relative to the base edge, and then move it back and forth with light pressure with your index finger over the cutting surface, okay? And that is basically knocking the burr off that you created when you filed the side edge. And that's all you're doing. So does that answer your question?
Yeah, so doing it that way, like it doesn't damage the base of the ski?
No, not if it's, the only way it would damage the base of the ski, this guide is designed, it's a floating system, so it can't take more material off than the bevel angle that you're establishing, okay? If you've taken down the base edge too much, you're not going to contact the base edge at all. You may contact the plastic beside the base edge, in which case there'll be abrasion on there, right? So you have to be careful with that. And if that's the case, the only thing you can do, if you want to set that as a bevel angle, right? It's a lesser degree, is to take the skis into the shop, stone grind them to flat, reapply a lesser base bevel.
Okay.
So if you notice that, if you take an accurate tool, you run along the base, you mark it with a Sharpie, you're not touching the Sharpie at all. That's a pretty common thing actually, is too much base, too much of the base metal has been removed, and it's a more acute base bevel angle than you want. All right.
Okay.
It's also,
you're just not going to touch that part.
well, it's intimidating. A lot of people are intimidated by it, but it's actually really short. As long as you have an accurate tool and just one a 400 grit diamond stone, it's, you just make a couple passes, it just knocks off the burr right at the cutting surface, and that's it. And it doesn't require a lot of work, right? And it makes a pretty significant difference in performance. So something to consider. Yeah, and you can let, you know, if you take your skis into a reputable shop that knows what they're doing, that's really important, because there's a lot of shops with equipment, with robotic machines, for instance, that will stone grind your base and they'll set the edge bevels, but those bevel angles are not necessarily accurate. You have to be really careful. And my advice is to take your skis in at least once a season, at the beginning of the season. Let's say in the fall, September, to get them stone ground so the bases are flat and you've established the linear pattern, reestablished the linear pattern in the base. And that's called structure, the base structure. Normally for cold conditions, the base structure is fine, okay? I'll talk about that more when we go to the base. We'll talk about waxing. But basically, that's all that's involved with the base edge. Does that make sense?
Yep.
So the side edge is designed to be taken down over time. The base edge is not. You simply set the base bevel angle, and once it's set, it's just simply maintaining it. And that means knocking the burr off that's created when you file the side edge. Okay.
So do you need that tool if you're using a stone to do the base edge?
Yes. So if and you need, with this base edge bevel guide, you need a rectangular stone because it's long, and you can prop the file, the stone on on top of the shim. It's long enough to do that. So the pucks are used for side edge work. They're very efficient for that. You do need a rectangular stone for the base edge, and I'd recommend a 400 grit. Okay, so that basically covers everything that's involved with the edges. Okay, pretty straightforward, and I've done everything systematically from start to finish. Okay, and if you maintain that order, you're good to go. Any questions about that? All right. So now I'll progress to the base itself, and we'll discuss cleaning the base, waxing, and everything involved with the base. So the base material, what is the ski made of? Well, the base is made of what's called ultra high molecular weight polyethylene. Okay, and how is it made? It's formed. There's a powder, okay, that's formed in a cylinder under heat and pressure. And that cylinder is peeled or skived with a peeling machine into a sheet, okay? The sheet's cut to shape, that's your base. There's two components to the base. There's an amorphous structure and a crystalline structure. Nothing penetrates the microcrystals in the base, okay? But around these crystals in no particular order are gaps and voids, okay? That's the amorphous part of the base. Our challenge is to mechanically push wax into the amorphous part of the base, okay, and make it stay there as long as possible. Friction and abrasion from the snow is tearing the wax off the base, okay? Mapluce, the parent company of Mapluce in Italy, is the largest producer of Teflon in Europe, kind of a small version of DuPont, privately held DuPont, similar. They have extensive lab facilities, and we've used those facilities to basically understand what's happening with the base. So we've taken photos of the base under an electron microscope and used other measurement tools to understand what's actually taking place with the base, okay? So what we've found is that the base, you only get a very small amount of penetration of wax into the base, okay? So the base is very slippery, nothing sticks to it readily, that's why it slides. The maximum amount of penetration you get, regardless of what you put on the base, is 15 to 20 microns, okay? So to put that in perspective, that's less than the width of a human hair, substantially less. So it's a very small amount of penetration of wax, for instance, into the amorphous part of the base, okay? It goes just under the surface. It doesn't, the wax, the base is not a sponge. It doesn't absorb and exude wax as necessary. There's a lot of wives' tales about, pores in the base and that type of thing. There aren't pores in the base. There's basically gaps and valleys, okay? The amorphous part, you're trying to mechanically press wax into that area, make it stay there as long as possible. Friction and abrasion is tearing it away, okay? So does that kind of give you that's a crash course on what we do when we wax? That's primarily what's involved with that. So it's important with the base to clean it properly, okay? There's three ways to clean a base prior to applying wax. So the least effective way to clean a base is with a metal, typically a brass or bronze brush, okay? And what I do is I just basically run the brush down the length of the base. And what that does is it opens the linear pattern. It opens the structure. It basically brushes wax out of the structure of the ski, okay? But whatever's underneath the linear pattern that's actually in the base is still contaminated. So that's why it's the least effective way to clean a ski. A second way to clean a ski, more effective, would be to take a soft paraffin, like soft base, okay? So it has a low melt point. It's a warm conditioned wax. In this case, -5 to 0. I'd apply a liberal coating on the base with an iron, okay? I'd scrape the base when it's still warm. The wax is still soft. And what that does is it basically blends contaminants. So you've applied new wax, you've blended the contaminants that are on the base and in the base with the new wax, and then you're scraping most of the wax off, okay? If you continue to do that, apply another coat of the soft base, iron it in, scrape it off. You're factoring down the level of contamination through multiple applications, all right? So that's a more effective way to clean the base than just using a brush. The most effective way to clean a base is with a detergent. So in our case, we have what's called clean detergent. It's a gentle detergent that's used to remove paraffin and contaminants from the base, okay? So normally what we do with this detergent is we shake this thoroughly if it's in the container, pour a small amount in a cup or a mug. We use a paintbrush to apply it, either a 1-inch nylon or horsehair paintbrush, and we paint the liquid onto the base. It's actually a solvent. It's detergent dissolved in a solvent. So you'll paint that on. You'll allow the detergent to work for a couple of minutes. You can aid the detergent working by dedicating a bronze or brass brush, okay, that agitates the base while you're applying this detergent. That will speed up the process. The caveat is you have to save. You can't use this brush for after waxing, because you've applied wax. You'll have detergent on the brush, and you're defeating the purpose of waxing. So you have to dedicate the brush and only use it for cleaning. Okay. If you don't use a brush for cleaning, you can just apply it, let it sit on the base, and allow some time for the detergent to work before it evaporates, or while it's still liquid. Typically, we'll take a towel wrapped around a scraper. Okay. In this case, for racing, we use what's called fiber lean towel because it doesn't give off lint. So technically, lint is a contaminant. All right. And what I'll do is I'll gently wrap the towel around the scraper loosely. Okay. And I mean, I can show you. I've got a container with a pump, and I'll apply the detergent down the length of the base. Okay, I'll allow it to work for a couple minutes. Then I'll take the towel. Let's assume that a couple minutes have passed, and I'll draw the towel down the base. Okay, and you'll notice that there's a black line on the towel. Okay, that's the contaminants coming off the base. So I'll rotate this to a clean section of towel, and I'll repeat, drawing the scraper down the base. Okay, you'll see it again. Keep doing that basically until that line disappears. Okay, if you've removed all the solvent and there's still a line there, reapply. But eventually you'll get to a point where there's no line. That means the ski is clean, and then I'll dry the base. Okay, using the towel, clean section of towel, I'll dry the base. The base is now effectively clean. If you don't use fiberline is for racing. It's more expensive. You can use a shop towel or even a household towel. If you do use a household towel or a shop towel, you are putting lint on the base. Technically, lint's a contaminant for racing. So if you're prepping the skis for racing, it's better to use fiberline or a lint-free towel. So that's the most effective way to clean a base. Now, there's wives' tales out there about cleaning the base, okay? Some people claim applying a solvent on the base will dry the base out. Technically, that's bunk, because regardless of what you put on the base, the maximum amount of penetration into the base is 15 to 20 microns. It doesn't matter if it's a solvent, if it's wax, if it's acid rain, pine needles, whatever the contaminant is you're running over, okay, the maximum penetration into the base is 15 microns. And so applying the solvent, it's maximized the penetration at 15 to 20 microns. That technically means it's impossible to dry the base out. What normally happens is, especially with a black base has a carbon content. And if you're skiing on abrasive man-made snow, for instance, typically along the edges, you'll get some abrasion over time. And when you clean the ski thoroughly, all of a sudden you'll see this chalky appearance along the edge. A lot of people mistake that for being dry, the ski being dry. Basically, some of the carbon has been pulled out of the ski by the abrasion, and there's a chalky appearance. That goes away after you reapply wax, okay? There's also some surface oxidation that takes place when you clean the ski. Again, when you apply wax, that's eliminated. So, not a problem to use a detergent. The caveat is when you use a detergent to clean the base, you have to put the wax back in the base, okay? And that's what's called saturation. So we have to resaturate the base with wax because we've stripped all the wax out of the base. So in order to do that, we'll use a soft paraffin. Before I get to that, we talked earlier about the structure in the base, the linear pattern. The reason you have a linear pattern in the base, or if you look at the base, it's not shiny, okay? There's some lines in it, is that those lines mitigate suction, the effect of suction. So if the ski is perfectly smooth, the base is shiny. If you're running over a puddle in the springtime with your skis and your skis stop, and you go forward, you go forward, but your skis don't, that's suction. And so the linear pattern is a mechanical means, basically, of channeling water down the base and out the back of the base of the ski. And that breaks the effect or mitigates the effect of suction, okay? So when you're traveling on snow, you're actually traveling on a very thin layer of water. The colder it is in winter conditions, it'll be a very thin layer of water, okay? And in that case, you need a fine structure. A fine structure is sufficient to channel that minimal amount of water out the back of the base. In spring conditions where you have a high moisture content in the snow, you've got a thicker layer of water. Typically, we put a coarse grind in the ski because you have to channel more water out the back of the base. So we use a coarser grind is more effective in spring-like conditions where you have a high moisture content in the snow. So that's the purpose of structure, okay? I didn't elaborate on that earlier. So we'll apply, basically after we clean the ski thoroughly, we've stripped all of the paraffin out of the base. We need to resaturate the base, okay? The best material to resaturate the base is a low melt point paraffin, a soft paraffin, okay? It melts at a lower temperature and it stays liquid longer. So if I was to take a harder paraffin, for instance, so med base, in this case, that's minus 10 to minus 5 Celsius. You can use it in down to, I've used it in minus 15, minus 17. It's a harder paraffin. If you apply that paraffin, it has a higher melt point, and you apply that on the base, you run the iron over it. Immediately after you run the iron over it, it solidifies. So it doesn't penetrate into the amorphous part of the base very well that we talked about. So our wax, first of all, is always designed to be applied on a clean ski. If you apply it on a dirty ski, then you affect the glide properties of the wax because the ski is contaminated, okay? Technically, when you put the skis on snow, you go skiing, you've contaminated the base. So you need to clean the ski thoroughly. You need to apply a saturation material. All of our waxes, regardless of temperature, we always apply a saturation wax before what is called a wax of the day if it's colder, right? So in warm conditions, if it's minus 5 to 0, which is what this wax is designed for, snow temperature, we'll apply this wax as a saturation layer, iron it in thoroughly, allow the skis to cool 15 to 20 minutes, okay? And then once they've cooled, bring them back. Ideally, you want to iron that material again, like iron the wax again after the wax is cooled. You don't get better penetration. You maximize the penetration with the heat source, with the iron at 15 to 20 microns. But the more often you can reheat the material through a warming and cooling cycle, the better the coverage you get across the base. So for instance, if I apply a layer of soft base, iron it in, allow it to cool, scrape it and brush it. If I take a picture of the base under an electron microscope, there's very sporadic coverage. Okay, so it's not covering the entire base. The more often I can reheat the material, allow it to cool 15 to 20 minutes, bring it back, reheat again, the better the coverage. So if you're racing, it's really important to do that as many times as possible with a solid. Okay, as a practical matter, you can't just do it endlessly. So you might want to do it over an hour or so, maybe 2 or 3 reheating applications. Once the ski cools, the last time you do it, then you're going to scrape the material off and brush, right? At that point, if the temperature, the snow temperature is -5 to 0, you can go out skiing on the base saturation wax, okay? If the temperature is colder, then we'll apply a harder layer of wax that's temperature specific to harden, what's called harden the base. So what we're trying to do is we're trying to match the hardness of the snow with the hardness of the base, and hopefully make the base a little bit harder than the snow so that we have more durability, okay? So we're approximately trying to match the hardness of the base with the hardness of the snow. So we'll apply a temperature specific wax that's harder, let's say red, that's -7 to -3, violet, -12 to -6 degrees. Those are great waxes to harden the base. If it's extremely cold, we'll use what's called Arctic base. We can blend that. That's a powder. We can blend it with a violet or a red in order to further harden the base for extreme cold conditions. So with the saturation material, what is the purpose of saturation? Okay, why are we trying to fill up the amorphous part of the base? The answer is to prevent dirt from getting in. So it's a protection measure. So saturating the base is a protection measure. Then we put on a second wax if it's colder. That's a dedicated wax of the day, okay? What's called wax of the day in Nordic skiing and cross-country skiing, they refer to it as a wax of the day. That's a second layer that's harder, and we apply that to be condition specific. Does that make sense? So a lot of people, they'll look at the temperature where they're skiing, they'll say, okay, it's -15, I'm going to apply a hard wax. They don't saturate the base adequately, okay? And that's not ideal. It's better to saturate the base first, okay? Scrape, brush, and then apply your condition specific wax on top of that. There's other types of wax. I'm referring specifically to paraffin right now. Mapleuse is the largest producer of Teflon, as I mentioned, in Europe. They're also one of a handful of companies globally that's producing the fluoro material that goes in ski wax. So fluoro or fluorocarbon is blended with paraffin, and it's very good at repelling water, okay, and dirt to some extent, but specifically it's very hydrophobic. And so in warm conditions with higher moisture content, you get a benefit from applying fluoro. And so we have low fluoro material, low fluoro wax. Our fluoro content is approximately 3% fluoro and the rest blended with paraffin, okay? High fluoro, approximately 10% fluoro content blended with paraffin. And then we have perfluorinated material that are overlays that are used as what are called accelerators in top level racing. But for your purpose, I'm specifically talking about paraffin. We also have additives that go in wax for specific conditions. So one of them is molybdenum. Okay, so it's we add that to wax. It's used specifically if there's extreme cold conditions where there's very little humidity, approaching 0% humidity, relative humidity. We use molybdenum because it mitigates the effect of static electricity. We're more concerned about static in those circumstances really than glide. Also, if there's physical rain on the course, molybdenum works well. There's other materials that we use in wax as well. But for the purpose of this workshop, I'll limit it to paraffin unless you guys have specific questions. It's okay? All right. So we've talked about saturating. Okay. We've talked about applying a second harder layer to harden the base. Scraping. When you scrape, it's important to keep your scraper sharp. Okay. So for instance, with this tool, the 0 degree side, if that's outward facing, you can place that on a flat surface over top of some sandpaper, move that back and forth, and that'll sharpen your scraper. Good idea to keep it sharp. A sharp scraper does less damage to the base, to the structure of the ski. A dull scraper will do more damage to the base. So any scraping damages the base, but it's minimized if you use a sharp scraper. Okay, and you'll scrape the base, you'll scrape all the residual wax off the base, the surface of the base. And then we use brushes, basically, well, they're used for different purposes. So normally we use a metal brush, either a steel brush, brass or bronze brush, is a first brush before waxing. Okay, so after we've cleaned the base, we'll use a brass or a bronze brush to open the structure of the base. Okay, so after we've cleaned it, to open the linear pattern and the structure of the base, we use a brass or a bronze brush. Okay, it's also the first brush we use after waxing to reopen the base. Okay, so after we scrape the ski, basically we scrape all of the residual wax off the surface of the base, but there's still wax in the grooves, right? And if we're using a brush with this brass bristle, we'll penetrate the linear pattern, the structure, and we'll reopen the structure of the ski. So that's a brass or a bronze brush, okay? The second brush we use after we use the metal brush is a horsehair brush. Horsehair is the best bristle for sweeping debris. So after we've reopened the base using the brass or the bronze, okay, we'll use the horsehair to sweep the base, debris from the base. And then normally, finally, we'll finish with a nylon brush. Nylon is the best brush for buffing and polishing the base, okay? So a lot of people have the misconception that they should use brushes according to hardness of the bristle. So in that case, you use a brass or bronze, that's the hardest bristle. That would be the initial brush, that's fine. Then they say, okay, followed by nylon, which is harder than the horsehair, okay? So the nylon in that case would be the middle brush. Then you finish with the horsehair. It doesn't work that way. Basically, you want to select your brushes according to what they do, okay? So the brass or the bronze brush opens the base structure. The horsehair sweeps debris. It can't buff or polish the base, okay? The nylon bristle is used last to buff and polish the base. The only time that these two brushes would be reversed is if it's extremely cold, okay? And that window where we talked about using extremely cold wax or molybdenum mixed with wax, where there's very low humidity and it's extremely cold, we tend to finish with a horsehair brush because it's a natural fiber and it generates less static than a synthetic fiber, which is nylon, okay? But overwhelmingly for almost all conditions, you'll use a bronze or a brass to open the structure of the base, followed by a horsehair, and finish with a nylon.
So Rick, when you're saying to reopen the structure, you're basically taking away the smoothness of the wax and you're going back to the linear pattern that evacuates the water from front to back? Is that's the scoop?
Exactly. The goal is to remove all residual wax off the surface of the base and just leave the wax in the base, okay? So you won't do that completely, but the goal is to reopen the structure as much as possible to facilitate, the mechanical
the conduits.
The conduits, yeah, exactly. That's right.
Okay.
Yeah. So there's different types of brushes, okay? We have rectangular brushes. These are the least expensive. All of our brushes are made in Germany, so they're very high quality. They're produced in an area that where beechwood is prevalent, and for again hundreds of years they've produced brushes and they've gotten very good at it. So we have all of our brushes produced in Germany, and they're very high quality. So rectangular is the least expensive. We have oval brushes, okay, that it's like a horse brush with a strap, and that's a bit more ergonomic, a bit more comfortable in the hand. There's more surface area, more bristles, and a lot of servicemen tend to prefer oval brushes. We also have roto brushes. So if you're maintaining several pairs of skis on an ongoing basis, we have a handle that we manufacture. It's entirely metal. It has a feature so you can snap it on and off the hex drive. This is a hex drive. And then we have a roto brush. This is a bronze brush. We have horsehair and nylon. And you snap the handle on, and always wear eye protection, but this automates the brushing process. And most people don't brush properly while they're brushing your teeth. They tend to leave a lot of residual wax in the base, right? And this will pretty much eliminate any possibility of doing that, and it's a lot easier. So to brush the skis adequately, properly, you need a lot of elbow grease, and you need to put a lot of effort into it. This will basically automate the process, right? And so if you're using a rotor brush, always wear eye protection, okay, very important. And when I'm running down the base, I'm going to be, depending on which side of the bench I'm on, I'm either going clockwise or counterclockwise. And I want the rotation of the brush to provide resistance. So I don't want the brush pulling me forward like a car rolling forward. I want it going so that it's actually providing resistance and brushing debris up in front of me. So a mask is a good idea. You're dealing with particulate matter, okay, and definitely eye protection if you're using a rotor brush. But something to consider. A lot of people initially they'll buy hand brushes, and then they'll realize how much work's involved, and then they'll gravitate to a roto system. So just a heads up. Also, we have other types of brushes. We have merino wool brushes, which is technically a microfiber, okay, and that's a roller that's used like a roto brush, and that penetrates, because it's thinner than a bristle, it tends to penetrate deeper into the base structure, and it also generates some heat. So there's a very even distribution of wax, okay? So that's another material that we use in place of bristles, effectively, merino wool. So any questions about brushing? Or so that's the final step in the process, the waxing process to prepare the ski. Okay. With wax, we also have liquid wax. So I'll briefly explain that to you because that's an alternative to a solid. Okay. With liquid wax, we basically have three waxes. We have hot, okay, which is our saturation material, and also warm conditioned wax. We have med, which is -9 to -2, so that's a middle hardness, and then we have cold, which is -22 to -8. Okay, liquid wax is basically the same material that we have in solid, dissolved in a naphtha-based solvent. And there's certain advantages to using liquid wax. So let's say 30 years ago, liquid wax kind of got a bad rap because it's very easy to dissolve a low melt point paraffin, a soft wax, in a solvent. The problem is, because the wax is so soft, it's not very durable. So with wax, durability is directly related to hardness. So about 15 years ago, Mapleuse patented a process to basically dissolve a high melt point paraffin in a solvent as opposed to a low melt point paraffin. So all of our harder waxes are what are called Fissure Trough paraffins, okay? And Fissure Trough is a process where coal is converted to natural gas, okay? And in that process, it produces what's called a synthetic paraffin. There's 1,000 different ways to call something synthetic, but in our case, the molecular size is consistent, okay? And that paraffin is far harder than a normal wax. It's more expensive. It's also far harder. So we've managed to dissolve a high melt point paraffin in a solvent, which addresses the durability issue, okay? So our liquid wax is highly durable. And so with liquid wax, if we were using this, we shake it thoroughly, apply a very small amount in a cup or mug, paint it on with a paintbrush, again, a lot like the solvent, but it has to be dedicated. You can't use the solvent brush. You paint it on in 15 centimeter increments. Then you'd immediately rub and press with a cork. Okay, so after you've applied it, you rub and press with a cork in 15, let's say 15 centimeter increments down the entire length of the base. Okay, you only have to apply this once. You don't have to keep reheating it like you would with a solid. Okay, and after you've applied it, you'll notice that there's a chalky appearance. That's perfectly normal. Allow it to harden for about 5 minutes, thereabouts. And then you can make a decision. You can either go direct to your brushes, right? Or you can proceed to iron the material, the wax in, the liquid wax into the base using an iron. And ironing it will give you additional durability. And what we do with the iron is we have a sheet of Teflon. So we have the iron. We'll place the Teflon under the sole plate of the iron, between the base and the sole plate, and then we'll draw the iron down the length of the base, okay, with the Teflon. Basically, with liquid wax, you have an extremely thin layer. It's very efficient relative to solid, and it's very thin. So what this Teflon sheet does is it basically provides a buffer so you don't get as direct a heat transfer into the base, right? And it also prevents the base edge grinding against the metal sole plate of the iron. So in the case of liquid, you have to be specific with the iron setting, okay? It has to be the setting that's appropriate for the wax, either the hot, the wet, or the cold. So the temperature has to be correct. And you have to trust the process because you don't see the iron, you don't see the wax pooling. So if you're applying a solid with an iron, ideally you have 4 to 6 inches behind the sole plate where it starts to solidify. You see it solidifying. If the iron is smoking, it's too hot, right? If the iron isn't melting the wax, too cold. With liquid wax, it has to be the correct setting from the beginning. And you have to trust the process because you just see a chalky appearance on the base. The advantage is that you don't have to scrape, right? So scraping, especially a hard wax, like a harder paraffin, is almost like chiseling it off the base in some instances. And the application of a hard paraffin as a liquid is the same as a soft paraffin liquid. So there's no need to have to really work hard to much more difficult to work a hard paraffin solid than it is to apply liquid wax. So in terms of coverage, applying a liquid, you almost and using an iron, you have almost absolute coverage the first time you apply a liquid. Our research shows that it takes up to 25 to 30 times reheating a solid and allowing it to cool, then reheating it again to approach the same coverage you get applying a liquid using an iron the first time. So in top level racing, we use liquids quite extensively, actually. Not a lot of people know that, but we use sprays and liquids because they provide superior coverage. We tend to use solids for durability. So any questions about that? So I think that basically covers everything. So I've how are we for time? Yeah, we're approaching 9 o'clock. Any questions? Do you guys have anything specific that I didn't cover, or
Nope.
we're good?
All good.
All right. Well, that's great. So, no, I appreciate you showing interest and sticking with me.
I guess one quick question. I was just looking at your website, like the Pro Sharpener compared to the green and red one there.
Yeah. I prefer the green and red one to the Pro Sharp has a fixed position for the file, so you can't angle the file, and it's an 80 file, so only the very front and back of the file is touching the edge that I explained earlier. Yep. So it's far more versatile to have a file guide where you can use both files and stones, and you can angle them appropriately, and you can use more of the file or stone as a usable surface, right? And it's far more efficient. So if you're going to be doing this frequently, it's a better idea to invest in a file guide as opposed to a universal guide, that type of thing. Yeah, I definitely recommend that.
This is kind of a difficult question, but for stones, how do you know when they're junk? When you need to get new ones, start fresh again?
Yeah, good question. It's actually tough to tell visually, like almost impossible to tell. You have to feel. So with a stone, the easiest thing to do is to take the same grit, a new sheet of material, and compare it to the old, right?
Okay.
If you don't have that, using them wet and then using the toothbrush periodically to flush the stone will actually prolong the life, because the stones tend to get clogged.
Yeah.
And if you don't flush them over time, debris will accumulate, and it'll actually overwhelm the level of the diamond. And then in that case, it becomes, you can't use it effectively, right?
Yes, same as sandpaper when you're sanding something and it clogs up, right? Exact same. Okay.
Yeah. And so, but over time, with wear, they will wear out. So if the best thing is when you first get the stone to feel it, and then to compare it against that as you use it. If it becomes, basically when you're using it, if it's not cutting, or the file doesn't bite any longer, for instance, with a file, then it's likely time to get a new file.
Okay.
Our files and stones are very high quality, so you'll likely get, you should get at least a season's use out of our material, depending on how much you use it. But it's kind of a good rule of thumb to replace your diamond fabric after each season, and as well as your files. Yeah. But to answer your question, visually, it's you really difficult. You can't really tell. You have to feel them, and when you're using them, if they're not cutting effectively, that's the best, the easiest way to tell.
Well, thank you so much.
Great. Okay. Well, yeah. Enjoy your evening. Thanks a lot.
Thanks,
so for ordering with the NASA discount, can we do it online or do we need to come in?
Yes. No, you can do it online. We have a discount code, NASA 20. All capital letters, followed by 20. And then you can select, if it's a local pickup, you can select local pickup if you want to come in. Otherwise, we can either ship it to you or in season, we tend to deliver on a weekly basis within Calgary. So we can do that.
Where are you guys located, actually?
Yeah, we're in Mindapore, so we're right across the street from the Fish Creek LRT station.
Oh.
So kind of deep south.
Chinook is like deep south to me.
Yeah, we're a few minutes further south. But you can see our building from the Quadrille, so we're really we're pretty set.
Okay. Well, perfect. Thanks so much.
Yeah, you're welcome. Okay, have a great evening.
You too, Rick. Thanks.
Thanks.
Bye.